We're going to focus on graphing linear equations, specifically linear systems. I should have wrote that in actually. We're going to say solving linear systems, which is essentially where two lines, where do they intersect? So in our equation here, in this graph, they kind of intersect there. So the very first thing we need to do is graph each of the linear equations. So I'll call this linear equation 1 and linear equation 2. One of the most common ways of graphing a linear equation is putting it in the y equals mx plus b form, which is essentially, we put it into a form, we set it equal to y. The coefficient in front of the x variable, that's going to be your slope. It's going to be like the slope of the line. And the b stands for the y-intercept, wherever that line crosses the y-axis. Okay, so that's what our constant will be. The very first equation, we've kind of lucked out. It's already set up in that way for us. If I move this over, we can quickly see that our slope is 2, and our y-intercept is -3. So if I go to graph that, that works out really nicely for me. I'll do a little... Actually, I have some graphs over here. Use the pictures. There we go. That's y-axis, scale of 1. That's better. There you go. Sorry, let's bring that down. Okay, so if we go to graph this, what we want to do is we want to start at our coordinate, the one value we do know, which is the y-intercept. The y-intercept in this case is -3. We'll do this line in green. So I look on my graph, I look for -3. That's this value here. So that's going to be my starting point. And then my slope. My slope is 2. The only downside of that is slope is usually written as rise over run.
So it'll be 2 over 1.
Yes. So you always want to kind of convert your slope to a fraction, and because this is a whole number, to convert to a fraction, you put it over the value of 1. So the rise is 2, and the run is 1. So what does that mean? That means we have 2 over 1, or, so we're aware that this is positive. I can do the opposite on both. I can go -2 over -1. The reason that works is a negative divided by a negative is still positive, so it's still a positive slope. So I rise, I go up, 1, 2, and I go to the right, +1. So that was +1, +2, +1. There's our slope. And the reverse of that, -2 is down 2, 1, 2, and -1 is to the left 1. There's our next point. So we now have 3 points along, and we can continue that pattern. 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, 2 over 1. I'll do my best to fit a line here. Let's start here. Here's kind of our line. Okay. Actually, take that away. Let's make our line green. And so it's a little more controlled. Okay, so we did the very first one. Now for the second question. Well, the second question is a bit harder. First of all, we're not in this y equals mx plus b. So we need to do that. In order to do that, we want to isolate for y, which means we want to move all the other terms to the other side of the equation. So that's this positive 4x and this -9. Now, I can move those two, or I could just move the y. That would work also. I will quickly, below the graph, show you the difference between the two and how they're roughly about the same number of steps. Okay, so I'm going to start it again down here. Y, what did I say, positive 4x, -9 equals 0. Okay, so let's try the two versions. In the first version, we're going to move the y over. Okay, when I do that, I'm left with 4x minus 9 equals -y. Okay, and technically we're not isolating for -y, we're isolating for positive y. So there's another step involved. The other step is I need to convert this to positive. So whatever I do this side of the equation, I must do the other. I can either divide by -1 or multiply by -1. It's going to have the same effect. So if I multiply all the terms by -1, okay, the y on the right side, that's going to change to just y. And this will change to -4x and +9. And because we're used to writing y on the left and everything, I'm just going to quickly rearrange it. There's nothing wrong with doing this. Y equals -4x plus 9. Okay, I kept all the values, operations the same. And now we're in our y equals mx plus b state. The other option here is I could have left y by itself and moved everything else. The first thing I would have moved was 4, which would have been negative 4x, and this would become positive 9. So if you look again, it's actually a little quicker. Negative 4x, positive 9. It's kind of like one less step to do it this way. Still the exact same answer. What does this mean for graphing? Well, y equals mx plus b. I always write it underneath just so it's a little simpler to visually see my slope and my y-intercept. My slope is negative 4. My y-intercept is positive 9. So, like we said before, we're going to start at positive 9. I'll draw this line in blue. So positive 9, I go to my graph. Here we go on the y-intercept. Here's my positive 9. And my slope. Well, like we said, we want to make it a fraction. So it's negative 4 over 1, or it's positive 4 over negative 1. Both are the same, and they both give us a negative answer. So I can go down 4, 1, 2, 3, 4, and to the right 1. Or I can go up 4, 1, 2, 3, 4, and to the left 1. I know that fell off our graph, but that's essentially doing the same thing. I'm going to go down another 4, 1, 2, 3, 4, to the right 1. Looks like we found our point. And I'll continue one more time past. 1, 2, 3, 4, and then past. Now I'm going to draw my line in blue here. I'm going to start it here and hopefully get it roughly great. So it looks like, again we're estimating, but it looks like the point of intersection here is going to be the x value 2 and the y value 1. So it looks at 2, 1 is where these two lines intersect each other. We can be a lot more accurate if we decide to go through elimination substitution to double check that, but from the view that's what it looks like it's going to be.